This is a question here that when it really boils down to is just stoichiometry. And so we're told that delta concentration of Br2, so the change in the concentration of Br2 over a certain period of time is equal to 4.8 times 10 to negative 6 molarity per second, moles per liters per second. And we're asked to figure out now delta of ClO2 minus over the same period of time. And so what this really becomes is just stoichiometry. Remember, whenever we're producing 2 moles of Br2, we have to consume 1 mole of ClO2 minus, 4 moles of Br minus. There's not, like, these have to be related at all times. And so what we can see is that for every single 1 mole of ClO2 minus that's consumed, we're producing 2 moles of Br2, which is to say that the rate of production of Br2, which is 4.8 times 10 to negative 6, will be twice as much as the rate that this is consumed. And so we're going to take this number and divide it by 2. However, because we're on opposite sides of the reaction, we're producing it here, but consuming it here, the amount of ClO2 minus keeps going down. So the number has to be both negative and divided by 2. So negative 2.4 times 10 to negative 6 moles per liters per second. Great. Next question is very similar. Now we're asked for the rate of Br minus. Now it's the opposite situation where we have 4 moles of Br minus consumed for every 2 moles of Br2 that's produced. In other words, this is being consumed twice as fast as Br2 is being produced. And so we're going to take this number, multiply it by 2, but because it's a reactant, we're keep getting less of this, have it be negative. And so it's going to be now the change in the concentration of Br minus over that certain period of time is going to be 9.6 times 10 to negative 6, negative again, moles per liters per second.